Welcome back everyone to Learning by Teaching. Today we're in dynamics and we're going to solve problem F15-18, and this is from the book of 12 edition. So someone put it down in the comments, so I'm just gonna answer this question. It says this guy weighs 2 pounds and slides on the smooth horizontal plane with a velocity of 3 feet per second. Disc B weighs 11 pounds and is initially at rest. If after the impact A has a velocity of 1 feet per second parallel to the positive x-axis, determine the speed of disc B after the impact. Okay, so we're given this figure over here. We got disc A, which is a little bit smaller. It's going at 3 feet per second. It's totally vertical. And disc B is basically at rest and is not moving. It's a little larger, so it weighs more. So the first thing I like to do in all these problems, always just write out my givens. Okay, so the first thing that they're giving is the weight of A. So we're going to write weight of A is equal to 2 pounds. And now this, we can translate it, therefore, as that the mass of A is going to be equal to the weight divided by the gravitational acceleration in imperial units, which is 32.2. And this will give me units of slugs. Okay, the next thing that they're giving me is that we have a velocity of A. So the velocity of A initially is equal to 3 feet per second, and as we saw, it's going to be totally vertical. Then they're giving me the weight of B, which is equal to 11 pounds, and we can translate this into the mass of B is equal to 11 divided by 32.2. The unit is slugs as well. And the last thing they're giving me is that the velocity of A after this impact is going to be equal to 1 feet per second. And notice that they're saying it's parallel to the positive axis. Well, parallel means that it looks like this, and to the positive axis, well, it makes sense that my disc B will do something like that. After hitting in here, it will have a final velocity just totally to the right. Okay, it kind of makes a little bit of sense, so I'm going to put an arrow representing that is totally horizontal to the right. Okay, we're asked to determine the speed of this big. So for this, what we're going to utilize is the conservation of linear momentum. Okay, where we need to add all the masses times its velocity has to be equal to the masses times their velocities after the impact. Okay, so the initial has to be equal to the final, just basically after the collision. And what we're going to do is we're basically going to divide this problem into the x direction and the y direction. What do they mean by that? So let's start. We're going to do the conservation of linear momentum, but in this case we're focusing on the x direction. Okay, so I'm going to assume that going to the right is positive, and we're going to add all the masses times their velocities in the initial state. So in the initial state, in the x direction, well, let's see. Let's start with A. A is going up, meaning that it has nothing in the x direction. So we have zero velocity. So plus, well, disc B is at rest, meaning no velocity at all. So 0. And all this has to be equal to the mass of A. So the mass of A, which is 2 over 32.2 multiplied by its velocity. Well, as we were given in the problem, it's 1 feet per second going to the right. Okay, so this is positive 1. And then we have plus the mass of B, which is 11 over 32.2 multiplied by the velocity of B, which we don't know. That's basically what we're asked for. And after the collision in the x direction. Okay, so as we can see in here, well, my left side is only 0. So what I can do is cancel out this 32.2 from both of our masses, and we're gonna end up having negative 2. So this 2, I'm gonna pass it to the other side, becomes negative 2 is equal to 11, the velocity of B, after the collision in the x direction. Finally, if we solve for the velocity of v after the collision in the x direction, this will give me a total of, so we plug this into our calculator, and we get negative 0.182 feet per second. Alright, so now we know one part of our velocity, which is the x direction. Now the second thing we're going to do is the same conservation of linear momentum, but in this case what we're going to do is focus on the y direction. So let me put this, then we're going to do in the y direction, okay? So for the y direction, we're going to assume that going up is positive, and let's see what we have. Well, for our disk A, we have 3 feet per second going up. Okay, so we have the mass of A, which is 2 over 32.2 multiplied by those 3 feet per second plus 0, because B is at rest at the beginning, has to be equal to, and then, well, the velocity of A after the collision was only given going to the right. That means that we have nothing going up or down. Therefore, we got 0 for our disk A. And for our disk B, well, we have the mass, which is 11 over 32.2 multiplied by its velocity, which is what we're trying to find after the collision in the y direction. Same thing happens in here. What we can do is cancel out the 32.2 from both terms that we have, and we will end up having 6 on the left has to be equal to 11, the velocity of B after the collision in the y direction. And when we solve for the velocity of B in the y direction after the collision, has to be equal to, well, 6 divided by 11 gives me a total of 0.545 feet per second. The last thing that we have to do in order to solve this problem is just basically we're going to apply Pythagorean theorem in order to find the magnitude of this velocity. So the magnitude of this velocity after the collision, so I'm going to give it a 2, has to be equal to the square root of, well, its x component, negative 0.182 squared, plus its y component, 0.545 squared. And if we plug this into our calculator, we will get a total of 0.575 feet per second. Okay, and this will be our final velocity for or speed for our disk B. So I hope you guys like the video. Please push the like button, subscribe, and I'll see you guys in the next one.